Hey everyone, welcome back to Civillearningon online YouTube channel. As we were learning inverse Laplace transformation and its application in ordinary differential equation. This is second example and I will continue that concept about the application of inverse Laplace transformation in simultaneous equation, and this is second example and also the last lecture on inverse Laplace transformation. After this I will start some new topics, so without any further delay, let's get started. So as you can see, we are asked to use the inverse Laplace transformation to solve the following simultaneous equation. Simultaneous equation, we are provided with the two equations, and we are provided with the boundary condition, that is at t equals to 0, x equals to 0 and y equals to 0. Similarly, dx by dt equals to 0 and dy by dt equals to 0. These things will be provided to us in the numerical. So we will proceed with the solution and writing the solution here. So write down the solution, and the second line will be again similar like what we have done in the previous lecture, that is taking Laplace transformation on both sides. So taking Laplace transformation on both sides. So on taking Laplace transformation on both sides, we will have Laplace transformation of d square x by dt. So I hope you remember the formula, that is Laplace transformation of d square x will be equals to s square Laplace transformation of x minus x0 minus x dash 0. Okay, so we have to use this formula here. So we have d square x upon dt square means this is second order derivative. Okay, second order derivative means we will have here s square x minus x0 minus x dash means dx by dt times at 0 plus 5 times 5 times dy by dt means s times s square times Laplace transformation of x. Similarly here we will have s times Laplace transformation of y minus, due to this 5 times dy by dt is 5 times s times Laplace transformation of y minus y0. Okay, similarly minus x means Laplace transformation of x equals to, and Laplace transformation of t. So Laplace transformation of t is 1 upon s square. S times x0 and s times x0. Here what happens, the power of s increases and power of x times 0 gets derivative each time. Similarly, let me make you clear this line with one more example. We have third order derivative of x, so it will be s square times Laplace transformation of x minus as dq means sq minus s square times x0 minus s times x dash 0 minus x double dash 0. This is how we proceed with while resolving this Laplace transformation of the derivative order. So this is what we get. Now we will write a like term as at one place. So we have here Laplace transformation of x and Laplace transformation of x. So we will have Laplace transformation of x times s square minus 1 and minus s x0. So at x equals to 0, we have this x0 means this is t. So at t equals to 0 we have x equals to 0. So at t equals to 0 we have x equals to 0. So this portion becomes 0, and x dash 0 is this portion, d x by dt equals to 0 means this will also get 0 and this will also get 0, and plus, and now we have Laplace 5 times 5s times Laplace transformation of y. So 5s times Laplace transformation of y, and y0. So at t equals to 0 we have, at t equals to 0 we have y equals to 0. So at y t equals to 0 we will have this portion 0. So minus 5s times Laplace transformation of y, and we have already taken this, and we will bring this side. So we have minus 1 upon s square equals to 0. This is for first equation. Now we will do again for the second equation. So again we will again take Laplace transformation for on both sides for this equation. So again we have here 2 times dx by dt. So we will have here 2 times s times Laplace transformation of x minus x0, okay, minus, again we have d square y, so we will write it as s square times Laplace transformation of y minus s times Laplace transformation of y, s times y0, okay, y0 minus y double dash 0, y0 is here, okay, and we have y, the derivative of y will be y dash 0, and we have plus 4y. So close this, plus 4 times Laplace transformation of y, and we have here minus 2. So 2 we Laplace transformation will be 2 upon s, because 2 times 1. So Laplace transformation of 1 is 1 by s. So this is what we get. Now put the boundary condition, that is 2s times Laplace transformation of x minus x0. So we have x0, x at t equals to 0 is 0, so this portion gets 0, minus s square times Laplace transformation of y, so s square times Laplace transformation of y, and we have y0 at y at t equals to 0, we have y equals to 0, 0, so this portion gets 0, and y dash 0 at t equals to 0, we have y dash, means dy by dt equals to 0, so this portion gets 0. So we have here 4 times Laplace transformation of y, so plus 4. So let's take Laplace transformation of y. I will do that in another step. So we have 4 times Laplace transformation of y equals to and bring this side, so 2 upon s equals to 0. Let's do one more step. So we will have 2s times Laplace transformation of x and minus common. So if we take minus common, we will have s square minus 4 times Laplace transformation of y minus 2 upon s equals to 0. So we have 2 equations. This is equation 1, this is equation 2. Now we will apply the Cramer's rule to find the value of Laplace transformation of x and Laplace transformation of y. How we are going to do this? See further. So we will write it as, now Laplace transformation of x upon equals to minus Laplace transformation of y upon equals to 1 upon. So what we will have here, we will simply cover for the Laplace transformation of x. So covering this, we have 5s constant as Laplace transformation of y, a minus 1 upon s square. So we will take this, like cover this, and we will have here, we are going to write here this 5s upon minus s square minus 4, okay, and here we will have minus 1 upon s square times minus 2 upon s. Similarly, Laplace transformation of y, we will have it as, so cover this, we will have s square minus 1 upon 2s, and we have here minus 1 upon s square minus 2 upon s, okay, and remaining we have here as cover this, so we will have here s square minus 1 times 2s, and here we will have 5s minus s square minus 4. Now here we will have Laplace transformation of x upon multiply this. While multiplying downward we take positive sign, and while multiplying upward we take negative sign and subtracting. So 5s times minus 2 upon s will be minus 10, okay, and minus will get plus, but while multiplying upward we take minus sign, so we are going to subtract this as minus, and this minus gets plus, and s square minus 4 upon s square. This is for Laplace transformation of x. Okay, now we will have equals to minus Laplace transformation of y upon, now multiply these two, so we will have here minus 2 means minus 2 s square minus 1 upon s, and multiplying these two, s and s gets cancelled, so we have up here 2 upon s, and minus will minus this minus, and well, we are moving upward, so that minus will make it plus 2 by s. Okay, now we have again 1 upon, and multiplying these two we will have here s square minus 1 s square minus 4, and this minus sign, and here on multiplying these two we will have here minus 10 s square. Now we will proceed toward the finding the value of Laplace transformation of x and Laplace transformation of y. So let's first find the Laplace value of Laplace transformation of x. So for Laplace transformation of x we will have here as taking first and last two terms, for first and last terms. So we will have Laplace transformation of x equals to minus 10 minus s square minus 4 by s square times 1 upon minus s square minus 1 s square minus 4 minus 10 s square. I have done simply the cross multiplication, this and this, so I have simply brought it that side because it is in division, so it is now in multiplication. So now let's resolve this. So we will have here taking minus common, so minus taken common, so 10 s square minus s square minus, we have taken minus common, so we have taken these two minus common, so minus, and 10 s square, 10 is multiplied with s square because here the denominator is 1, so on taking LCM we have s square, so 1 times s square and multiplied with 10, so 10 s square plus s square minus 4 upon s square times, and we are taking this minus also here, taking minus common from here also, so we will have here s square minus 1 s square minus 4 and plus 10 s square. Okay, so we have taken minus will get plus, and we will have here on numerator we will have here 10 plus 1, so 11 s square minus 4 upon s square times s square minus 1 s square minus 4 and plus 10 s square. Now what we will do, we will factorize this. So how we are going to factorize this? See here, we are factorizing this s square minus 1 and s square plus 1 and plus 10 s square. So we have multiplied these two, we got this, and plus 10 s square. On resolving this we got this form, and on adding we got this. Now we have factorized this s to the power 4 plus 5 s square plus 4, or you can simply rewrite it as put s square equals to a, so it is going to be as a square plus 5a plus 4. Okay, just for your understanding, so we can factorize it as a square plus 4a plus a plus 4, so a common, so a plus 4 and plus 1 common between them, so a plus 4, so we got a plus 4 times a plus 1, and we know that a equals to s square, so we have s square plus 4 and s square plus 1. So on factorizing this, we got 11 s square minus 4 upon s square times s square plus 1 and s square plus 4. Okay, so again we will now apply the concept of partial fraction to do the factorization of this. So guys, you can see here we have calculated simply on solving this and putting s equals to 0, we can get the value of b, and now we have some other constants also remaining, that is a, c, d, e and f. Now I am going to show you how to calculate those value. As you can see, we have a, b, c, d, e and f. So what we will do, we will do the comparison. Like we have one term as cube and we have fourth power, and here this if cs multiply with this power will be s to the power 5. So we can assume that this is actually 0 times s to the power 5 plus 0 times s to the power 4 plus 0 times s to the power 3. So if we compare the terms having highest power, so a times a when multiplied with s to the power 3, and when a s to the power 3 is multiplied with s square, this is going to be a s to the power 5. Now if we will look for that there is any chances of forming any other expression which will have constant as either a, b, c or d, and the variable as s to the power 5. So let's have a look in the equation. Like here we will have, like when cs will multiply with s to the power 4, we will have a variable as s to the power 5. So we have c s to the power 5 again. Okay, so again when this gets multiplied, we will have again s to the power 5. So we can write it as a plus c plus e equals to, and we will compare on other side of the equation. This is the concept which I have discussed in the my lecture on partial fraction. You should watch that lecture series also. So we will have a plus c plus e equals to 0. Similarly we will compare for b also. So b is when multiplied with power 4. We will look for other expression if there is any chances of forming expression which will have the variable s to the power 4, because we are considering s to the power 4. So when d is multiplied with s to the power 4, we will have one expression. Okay, and when f is multiplied with this, we will have one expression. So we will have b plus d plus f equals to 0. Okay, now let's compare the coefficient of s square. So if we compare the coefficient of s square on LHS, we will have 11 equals to, now look for the expression which could form s square. If b is multiplied with 5s square, it gets 5b. So we will have here. So next you can see here I have clearly mentioned everything, like how what is the coefficient of s to the power 5, coefficient of s to the power 4, coefficient of s square, coefficient of s cube, and here also the solution, like d plus f equals to, we have got the value of b as -1 here. So I have simply substituted the value of b here, and we got f equals to 1 minus d. Now if I imply this in this equation, we got the value of d and value of f. Now here also, like a plus 4c plus e equals to 0, so a plus e equals to minus c from here, so minus c plus 4c, so c equals to 0, and on substituting we got value of a and e equals to 0. So what we do, we are going to substitute this value here. So on doing so, we got Laplace transformation of x equals to, since here you can see we have got a equals to 0, so this gets cancelled out, so we have b value is -1, so 1 upon -1 upon s square. I am simply substituting the value which I have calculated, and cs is 0 and es is 0, so we will have here plus value of d value is 5, so 5 upon s square plus 1 plus e value is again 0, so and f value is -4, so -4 upon s square plus 4. Now simply you need to do the inverse, so x equals to minus inverse Laplace transformation of 1 upon s square plus 5 times inverse Laplace transformation of 1 upon s square plus 1 minus 4 times inverse Laplace transformation of 1 upon s square plus 4. Now from here we will get the value of x equals to, here we got minus t plus 5 sin t minus 2 sin 2t, because 2 can be written as 2 times 2, so a upon s square plus a square, so 2, this 2 is here 2, and 2 upon a and s square plus a is 4 is sin 2t. So this is for x. Similarly we will solve for y also. So while solving for y, we will have minus Laplace transformation of y equals to this portion is this multiplied by minus this 1 upon this portion is this value. So we will have on doing multiplication, we will get Laplace transformation of y equals to this value, and now we will do the need to do the partial fraction as we have done for x also. So on doing the partial fraction, we will go get this value. Now we will have y equals to inverse Laplace transformation of this minus inverse Laplace transformation of this plus inverse Laplace transformation of this. So on doing so, we will get the value of y also. This is our final answer, and I hope you enjoyed this today's lecture. See you in the next video. Till then, stay safe and take care of yourself. And this is the end of my series on inverse Laplace transformation. So in the next lecture, I will discuss about something new. So stay safe.